Hey everyone, today we're diving into the fascinating world of vapor degreasing, a cleaning process that is as cool as it sounds. Whether you're curious about how it works or just want to know how it can transform the way we tackle stubborn contamination, you're in the right place. Stick around because today we're going to break down what vapor degreasing is, how it works its magic, and why it's a go-to solution for cleaning precision parts. So let's get started. When choosing a cleaning process, one of the primary considerations is going to be the type of soil that needs to be removed. For example, soils like salts, carbonaceous smut, or oxidation are better suited for aqueous cleaning, whereas things like oils, greases, or buffing compounds are a better match for solvent cleaning. Now, just to be clear, in this case, when we say aqueous, we're talking about a chemistry that has water as its primary component. We use the term solvent, on the other hand, to describe a chemistry composed of mainly organic solvents like dichloroethylene. Vapor degreasing is a process that utilizes solvents. There are a variety of benefits that solvents can provide, including their low surface tension to allow wetting in small gaps, their ability to flash off to allow for easier drying, and extended bath life through recycling. In many industries, solvent cleaning is the standard. Now, some organic solvents can be dangerous or have health risks associated with them, and so today's products are formulated to minimize those risks and to align with EH&S guidelines. Now, on to the degreaser. This is a cross-section of a typical degreaser that has 4 main zones. The solvent starts in the boil sump, where the temperature is maintained at the boiling point of the solvent, which is typically anywhere from 60 degrees Fahrenheit to about 130 degrees Fahrenheit. The vaporized solvent goes up and saturates the air just above the sump in the zone known as the hot saturated vapor zone. Above that is what's called the freeboard zone. A series of chillers maintains this region very cold, which causes any solvent to condense and collect in the water separator. This is how the degreaser prevents solvent loss. Any water that also condenses ends up in this trap and is removed, and the solvent flows into the rinse sump, which is then overflown back into the boil sump, which closes our loop. A cleaning process utilizing this equipment would look something like this. Parts are placed into a rack or a basket and then slowly lowered into that hot saturated vapor. As the cool parts pass through this hot vapor, the pure solvent will condense on the part and drip off, which provides the initial cleaning. Many parts, though, will require immersion. The basket can be fully immersed to provide complete liquid coverage and some mechanical action provided by the bubbles. The basket is then raised out of the boil sump, allowed to drain, and then moved over into the rinse sump. Many times, ultrasonics are incorporated into this bath to remove the final remnants of soils from the parts. The basket is then raised out of the rinse sump and held in the hot vapor region to allow a final rinse from condensing vapors before it is slowly raised out of the vessel. At this point, you should have clean, dry parts ready to make their next step. And that's it. The vapor degreasing process is relatively simple. Now, there are a few minor details that I didn't get to touch on, but if you are thinking about adding a vapor degreaser or want to know more about the process, please feel free to leave a comment below or to send an email to AskDrAdam at KYZEN.com. Also, if you liked this content and want to be notified of future videos, make sure to subscribe and click the bell icon. Thanks again, and stay clean.